然后 the first one will be dealing about WebKitGTK, and the second will be about a keyboard library, EEK board, and the third one for Li Shiyuan will be talk about the Debian policy. And okay, then we welcome to our first speaker, Sam Lopez. Sam Lopez is working in Galia, and he's also very experienced in GTK and in GNOME development. And today his topic is about WebKit and GTK, a joint implementation of both, right? Okay, let's welcome.
Wow. What's this?
Oh, this is my book.
Yeah. Oh, does this in Magnus?
Sorry, I'm not familiar with my book. Oh, sorry. Hello, Sam.
Yeah.
This one is familiar with Mac.
Not Mac, but
Well, it's just
how to show the slideshow.
yeah.
Oh, so I got that, but
I think I just exported the PDF.
它两侧的画面都一样，可是两侧都投成那个 slideshow，两侧都投成那个这样子简报。Okay, good.
Okay, so I'm Sean Lopez, as he said. I've been working on GNOME for about 6 years now, or so. I'm a foundation member. I also work on the WebKit project, where I'm a reviewer. I have been involved since 2007, and I maintain the GTK port of WebKit. And I work for Igalia, which is a Spanish company, free software company. So first of all, I want to talk about what this talk is not about. I'm not going to talk about how web applications and the difference between web applications and desktop applications and how they are changing the way people see applications. So I'm not going to talk about any of this. I'm also not going to talk about the cloud or how to put data in the internet and how to make the desktop applications interact with that. I'm just going to focus on one thing, which is that the web as an application development platform is kind of winning against the desktop world. And what will be the reasons for this? One of them is that it's everywhere. If you write a web application, you can kind of assume that more or less everyone has a web browser and can use the application you write. So by writing web apps instead of desktop apps and just targeting one desktop like Windows or Mac or some Linux desktop, you can really reach lots of more people. Yesterday I was looking for some kind of data, and I saw this that says that there's close to 2 billion users of the internet with web access and internet access. I don't know if this is more or less accurate, but I don't know, since it was in the internet, I will just assume it's true. Also, another thing that web development has over desktop applications is that it's really easy to get started. You basically just need a text editor and a web browser, and you can just write something and make it appear on the web. And if this continues for a long time and the web really keeps catching up with the desktop and technologies and people keep writing just web applications, it might just happen very soon that the web will become the dominant platform in the future for application development instead of GNOME or anything else. And some of you in the audience might say, well, this is not really very different than now. GNOME is not really in any way the dominant the platform for application development, and you're right. So what we can do, we can try to do is something I did this time, instead of trying to keep fighting with Windows or Mac in pushing our desktop application development frameworks. Maybe you can try to catch up with the web and integrate the web into our way of developing applications. So what will be a reasonable plan to do this? I think has two steps. The first step we started a few years ago involves WebKit, which if you were in the talk that Holger did just now, he gave a reasonable introduction to what WebKit is, but if you were not there, just very briefly, it's a portable web engine that powers some of the most popular browsers nowadays, like Chromium and Safari. It's about 2 million lines of C++ code, and it's architecture in a way that allows it to be native in very different platforms. So what we wanted to do was to integrate WebKit into the GNOME platform. And for this we started WebKitGTK, which is a part of WebKit that it's written using the underlying libraries for the GNOME platform. So for instance, for graphics development we use Cairo, which is our graphics library. For network we use Soup. For accessibility we use ATK. For font rendering we use Pango, and so on. The list continues. So we use the platform. We expose native GTK APIs for all the functionality in WebKitGTK. So if you are writing GTK applications and you would want to use WebKit, we give you a series of widgets and APIs that you can use that are GeoTet based and are completely native for the platform. The main one is one called WebKit WebView, which is the basic viewer for the web content that you can embed in your application to show any kind of web-related content. Since we started this, the WebKitGTK project has really seen big adoption. It's used in many browsers, including Epiphany, which is the official GNOME browser, but it's also used in instant messaging clients like Empathy to do theming. So what they do is they get in macOS 10, I'm client in macOS 10 has theme files that are actually just HTML and CSS. So what they did is implement the support for those files, so you can show different kinds of layouts for your conversations, and they are compatible with the macOS 10 application. It's using email clients to render HTML emails. It's used to display the help in the GNOME desktop, and so on. The problem with this is we were missing a really important feature in the WebKitGTK platform, which was there was no easy way to access and modify the web content. We were not really giving the appropriate APIs to do so. So I will just show you a few examples of the kind of things we had to do in the past. Let's see. Yeah, so as you can see here, in March of 2009, I wanted to implement a translucent link message status bar. What this is basically just like in Chrome browser. If you have used it, when you hover over a link, actually I think I can show you an example. When you hover over a link, it will show this gray rectangle on the bottom, and when you hover away, it goes away. So I wanted to do something similar in Epiphany. So basically what you have to do, the solution I devised was to just inject some HTML code in the page that will show this rectangle. But as I said, there was really no convenient API to do so. So basically, I had to write this huge string of JavaScript code. And as you can see here, I put some fix me saying, get rid of this stuff as soon as possible. So it's basically this huge chunk that you write there, and then you just use a function which is called execute script. So you get the view, and you tell it, just get this string of JavaScript and execute it in your context. And well, it sort of works, but it has a very big problem that it's very difficult to debug. So if you made some mistake in this string, it's basically pretty complex to figure out what's going wrong. It's also very painful to write this and blah blah. So people were not really using this a lot. There was another way of doing this, which was using the JavaScript core API. So if you want to access the web content, another thing you can do is use the JavaScript core APIs, which are a C-based API for the JavaScript library that WebKit has. So for example, if you want to get the links in a web page, you just have to create a string using these APIs of JavaScript core, make a JavaScript value out of it, call it as a function, blah, blah, do sorts of things. I mean, just to do a very simple thing, it takes a lot of time, and you have to write very verbose code, which is not convenient to write. And this, in this example, some GNOME developer moved this implementation from using JavaScript core to using the new DOM APIs. And as you can see, he was able to do exactly the same thing using about 100 lines less of code. So, you know, that's a pretty impressive way of explaining the difference between the two kinds of APIs. So basically, until very recently, we were in this stage where we just had these two ways of accessing and changing the web content in a web view until, in both these examples, we are using the DOM APIs, which is basically the way you have to use and modify the content in a web page. In both of those, we are using JavaScript in one way or another. In one, we were writing JavaScript directly in a string. In the other, we were using some APIs. And actually, using JavaScript is the way most people know how to access the content in a web page or how to make them dynamic. So, I mean, this is one example that might be familiar to most of you. Just get the element in one page which has an ID of foo and just set a color of red for it. But actually, if you read the spec, the DOM says that it's designed to be used with any programming language. In order to provide a precise language-independent specification to the DOM interfaces, we have chosen to define the specification in OMG IDL, which this is not what it seems to be. It just means Object Management Group Interface Definition Language, which is a sort of a standard way of defining what an API looks like. So this is one real example of WebKit, is the ideal definition of document. And I mean, the details are not very important, but it tells you it's an interface, its superclass is Node, there's attributes, it has functions which have return values, parameters, it can have annotations that WebKit can use for different purposes. So since you have this, and WebKit is structured in a way that allows you to write code that, knowing the names and the types of these functions, you can actually use the underlying implementation of the DOM in WebKit. You can fairly easily write an implementation that uses GObject and C to access the DOM in the WebKit. So now I'm going to show you one example. I just wanted to ask how many of you are familiar with GObject and GTK programming? How many of you are familiar with GObject and GTK programming? Okay, not many of you. Okay, so maybe I can do it, I don't know, from scratch or something. So I will try to go slowly and explain everything I'm doing. Okay. To begin with, we have to include the WebKit headers. And then you are just going to write a simple GTK program. So we can do. First of all, we're going to create a window where we will show just everything we have. We have to initialize GTK. It's just there's some magical things we don't really care too much about. And in the end, we just run the main loop. The main loop is the thing that keeps waiting for the user input and will make the program react to what we do. So we create a new window. It's a top-level window. And we show it.